Alright, problem 16. It says, which drawing contains a pair of similar triangles? Now, similar means we've taken a triangle and it's sort of either been expanded or contracted, shrunk down a little bit. So we need to look at these four and decide which one of them happens to have similar triangles. Now, when I first look at this one, I notice that 22 and 11, that sets up in a nice ratio, 22 to 11. So for every 2 this is, that's 1. For every 2 that is, that's 1. That looks great. Also, the important part is also notice they have a vertical angle that matches here. So in this case, that's looking promising. But I want to go through and see why the others aren't going to work. If I look at this one, I notice it's 90 and 90. That's 30. Well, all triangles have to add up to 180 degrees. So 90 and 30 is 120. That makes this corner 60. 90 and 40, this corner here is going to have to be 50. Now, in order for triangles to be similar, all the angles are going to have to be the same. Because think about it, if you take a triangle and you expand it, the angles didn't change. Just the side lengths all grew at the same proportion. Here, right off, I can cross G out because they don't even have the angles matching up. Now, if I come to this one, this looks a little trickier, but wait a second. Here's what I see. I see 12 and 13. I can find this side right here, just looking at this triangle. I can find this measurement of this leg right here. Because I know that 12 squared plus this missing leg squared, we'll call it b squared, is equal to 13 squared from the Pythagorean theorem. Now, if we solve this through, you're going to find that this length right here, that b length, has to be 5. So this guy has measurements of 5, 12, 13. Notice they're all different. Where this triangle has 5 and 5, which would make this, in this case, would be 5 root 2, if you use your 45, 45, 90. But either way, you didn't even really need that because you can very quickly see that if these two match up in same length, the other triangle is going to have 2 legs match up, and they obviously do not. So right there, I can cross H off as a possibility. Now this one looks a little bit trickier, but if you remember, if you have these guys being parallel, you can use basically the side splitter theorem that would say 5 over 5 equals 8 over 6. Well, you know 5 over 5 doesn't equal 8 over 6. So you know that line and that line are not parallel. And if they're not parallel, there's no way those two can be similar triangles. So I come back to this one. And what I know is if I set up the proportion, notice you have this side in proportion to that, 11 to 12, as this side 12 is to 24. Notice they're both a half. But the key is these sides are in proportion, the angle is, as are these sides. There is a theorem we have, or a postulate, that says the side angle side, not for congruency, but to tell us whether there are similar triangles, where the sides are in proportion and you have an angle between them. In this case, the vertical angle matches. We know the triangles must be similar.